Okay, so let's look at number 9 and 10. It says, describe the number and nature of all the roots of each fifth degree polynomial of the functions that you see. Fifth degree. That means you're having something that is like x to the fifth power. That means that we may have a possible up to 5 x-intercepts, which means at most we will have 4 changes of direction. Okay? And those are those relative max or min where the bends happen and you're actually changing direction. Okay? So up to 4 are possible, and here we can count 1, 2, 3, and 4. The same over here, 1, 2, 3, and 4. So both of them are in fact fifth degree polynomials, and we're just going to describe the number and nature of all the roots. So for instance, this one is a root, and these are the roots that also occur. Okay? So because of the fact that it's x to the fifth, we know that we will have 5 roots, and we're just going to account for all of them, whether they're double roots, whether they're distinct roots, or whether they're imaginary roots. Okay? So let's look what we have here. So we have 4 x-intercepts, but I'm missing one of them because we're supposed to have 5. The one that it seems that I'm missing is actually a double root. Okay? Here is where it exists, and that's where they bounce off the x-axis. Remember, those are those double roots per se. So we could say that if I were to approximate 1, 2, 3, 4, 5, this double root happening at -5 would look something like this as a factor. The x plus 5 with the multiplicity of 2. Remember, if these powers are even numbers, 2, 4, 6, 8, that means it will bounce off of those that x-axis. Okay, so let's give this one like a -1, and this a +1, and this a +4. We would write those as x plus 1, x minus 1, and x minus 4. Again, because of these signs being opposite of what they are actually on the x-axis listed as. Now you notice all of these powers are to the power of 1. And the reason of that is because they cut through the x-axis, not bounce off the x-axis. So if that was a 1, or if these were 3s, or if they were 5s or 7s, any odd number, we know it's going to cut through that x-axis and not bounce. Okay? So listing them all, we're going to say we have, let me go ahead and make some room now that I kind of gave you the backstory of how you're really identifying all this. We know that we have one double root, and it is real, so one real double root. And the reason why it's real is because it actually touched the x-axis. Okay? And then we have these other ones. So this accounts for 2 of them. And now we just need the other 3. Because again, these are fifth degree polynomials, which means we should have 5. Okay? So I have one here, and another one here, which are basically showing this one, that one, and that one. So that's what these last ones are referring to. So all of these also are real roots. And they're real because they touch the x-axis, okay? And then last but not least, they're all different. So the way we're going to account for all 3 of those is we're going to say there are 3 distinct. Means they're all different. They're not the same. Like this double root, it's 2 of a kind. So we say 1 real double root, which accounts for 2. And then these 3 distinct roots, which counts for 3. So the total would be 5. So that's how you're going to describe number 9. Let's look at number 10. Again, we know that we have x to the fifth, so we have 5 roots up to possible 5 x-intercepts. So 5 x-intercepts. But you see, we don't have 5 x-intercepts. We have 1, 2, 3, and that's it. So these other 2, which could have been around here if it would have continued to come up, or in fact where these imaginary roots occur. Okay? So we're going to say three distinct roots. So distinct real roots or real zeros. Okay? And that's again those three that we see. Distinct meaning different, real meaning that they actually crossed or touched the x-axis. And then we're going to account for these double roots that could have, or sorry, not double roots, but imaginary roots that almost made it to the x-axis. And they're going to be two imaginary roots. You could say this as non-real. So imaginary roots, which would give us the total of 5. Okay, so just a little recap. If it has it to the x to the power of 5, we know that there should be 5, and you see there are 3 distinct, and then there are 2 imaginary roots. And still with that 4 changes the direction that satisfies everything. Alright.